This is the flip class video for lecture 1. This is what we are going to do in this video. We are going to cover two topics in this video. First, we will introduce the general concepts of how a computer works. And then we'll introduce the Moore's law, an observation that is consistently predicting the rate of growth of computer speed for decades. This is a typical computer you see off the street now. You use this for various different kinds of activities, such as surfing the web, playing video games, checking emails, preparing homework assignments, and so on. You will notice that in a typical computer, it consists of a monitor, a keyboard, a mouse, and the actual computer box. You use the keyboard and mouse to interact with the computer, while you see the feedback from the monitor. The word computer is derived from the word compute. Compute means calculate. So literally, computer is a calculator. Of course, it is not a simple calculator. It is a calculator that performs extremely complex calculation. So what are computers actually computing? Computers take input from you, perform the calculations, and then generate output. Generally, it reads information from you by the keyboard and mouse and other input devices, performs some very complex calculation, and then generates the results calculated on the monitor and other output devices. To sum up, this is the simplified general metaphor of computer. Input, process, and output. Computer takes input, performs some processing according to the program, and then generates output. As a programmer, the computer program you write defines how the computer is going to do the processing work. Computers only read input in binary form. Binary means 1 and 0. That means all input of computer has to be in the form of 1 and 0. You can use information of various forms as input. Numbers, text, photographs, voices, videos can all be used as input of computer. But they must be converted into binary form first. We will come back later on this issue in the semester when we discuss data representations. As I said, computer only process information in binary form, in 1 and 0. Historically, engineers use vacuum tube as a basic unit for processing binary data. This is a vacuum tube. Later on, scientists invented a device called transistor to replace the vacuum tube. This is a transistor. Notice that the size of the transistor is much smaller than a vacuum tube. That means you can pack a lot of transistor into a small area. As a result, the electronic circuits you can build can be a lot more complex using transistor. And that means your computer can be a lot faster with the complexity of the circuit. And then later on, integrated circuit was invented. This is an integrated circuit. Integrated circuit, also known as IC, is a set of electronic circuits built using a large amount of tiny transistors. The invention of integrated circuits further reduced the size of electronic circuits and increased the complexity and the speed of processors. As you can hear time to time again, the number of transistors you can pack inside of an integrated circuit determines the complexity of the circuits. And the complexity of the circuit determines the speed of the circuit. That means the more transistor in an integrated circuit, the more complex the circuits. The more complex the circuits, the faster the circuits. As technology progresses, the size of transistor is becoming smaller and smaller. And that means the number of transistors in an integrated circuit become larger, and the complexity become more complex, and the speed become faster. With current technology, the size of a transistor is smaller than the tip of a human hair. You may find over billions of transistors in one integrated circuit. Here is a plot of the number of transistors in an integrated circuit throughout the last 50 years. And that means this plot also represents the speed of computer for the last 50 years. This observation is known as the Moore's Law. It is named after Gordon Moore, who is the co-founder of Intel. Back in 1965, Gordon Moore observed that the number of transistors in an integrated circuit doubles approximately every 2 years. And this projected rate of growth continues for a few decades. So how do you apply Moore's Law? Many people are using the Moore's Law to predict the progress of technology. And more importantly, a lot of people are using the Moore's Law for technological development and marketing development planning. One of the most notable applications of Moore's Law is the launch of the Apple iPhone. This is the timeline of release years of the iPhone. Have you noticed that there is a new model of iPhone approximately every 2 years? The idea is that the number of transistors doubles every 2 years. That means we have another generation of computer every 2 years. Or the speed of computer becomes faster, that the customer can notice a difference for every 2 years. And they are willing to spend the money to buy a new device because they notice that there is a difference in speed. However, the rate of growth is slowing down in recent years. Note that the Moore's Law is just an observation or projection. This is not a physical or natural law. However, people are using this to make predictions related to computational power in the future. And the prediction it generates is quite useful for planning purposes. I hope this video provides you with some foundational knowledge of computer science. We will have some further discussions and problems during lecture time. See you in the lecture.